I just had a lot of fun making that thumbnail. I'm not going to tell you how many takes it was. That number is between 1 and 456. So, yeah, hey, Happy New Year. Happy holidays, everybody. Thanks for joining me. Got a Chapter 4 live review today. Going to take a look at some applications of derivatives, specifically related rates and optimization and first and second derivative tests and all that stuff. So, yeah, gonna kind of structure this one a little bit more because I know a lot of you are going to do the bulk of your studying this weekend, and so you might not, you may not have gotten into things yet. So definitely going to front load it a little bit so you guys can have some examples to look at and practice with. So I think it should be pretty fun. Just gonna wait for a couple people to join up. And yeah, I had a great holiday. It was great. We pretty much stayed local, visited a lot of family, and can't believe it was 2020. Wow, 2020. My seniors, you guys are graduating this year. This is your YOG, according to the Sunrise Show, Owen Crane. YOG. Very exciting, the year of graduation. Oh, we went from 1 viewer to 0 viewers. Oh, back to 1 viewer. Hello, my 1 viewer. Oh, I don't even have the chat open. Let's open up the chat. Pop out the chat. Okay. Hey, chat. What's going on, my 1 viewer? Once I can get confirmation from my 1 viewer that everything is working properly in regards to the tech, we'll get started. Because I know my late live review watchers, they just watch this part and laugh because they can just skip it right now. Just go ahead and just go ahead and go to the bottom scroll bar right there. Just zoop, skip it a little bit. Anyways, yeah, so I've got some problems planned. It's going to be pretty fun. I'm going to go ahead and actually get set up while we're waiting for confirmation from the chat. There we go. You know what, actually, is this going to bother anybody? I'm going to put myself over here, right on top of the calculator. How's that? No, I'll put it like right here. You don't really need to see me click buttons on the calculator, and I don't want to cover up anything that's on the screen. So I feel like that's going to be the best option. I'll actually turn the calculator on. On, I say. I was going to say, does it have dead batteries? It's a fake calculator, not going to have dead batteries. Hello, thanks for joining us. Anyone who's just joining us, hello, welcome. I've got some problems that I've prepped for tonight. Those problems are actually located on the planner. I'll go ahead and pull that up for you. Chapter 4 in the documents right here. If you go down to the bottom over here, additional review, this document right here, this is the problems I'm going to do tonight in the live review. Obviously, I won't post an answer key because I'm going to do them all out right now, but I figured it would be nice to have a copy of those problems. So hello, Owen Chef. Nice to see you. Yeah, so we're going to go ahead and get started as long as chat can verify that everything is working properly. Happy Friday, everybody. Happy Friday. I got to check the phone. Oh, we have a remind message from 7 minutes ago. Jackson Castell is clapping. Let's see if we can get that on there. Get that on footage. There it is. Jackson Castell is clapping. Sweet. Yeah, I'm a little late. Sorry. Got a little bit of a late start with bedtimes tonight. So, yeah, we were building a sweet puzzle piece. Actually, I could go get it. It's right there. We built this. It's like ice cream cone puzzles. They're kind of fun. Anyways, and anyone else in the chat, if you verify that everything is looking good, you can hear me okay, then I'll go ahead and get started. And as more people join, they can kind of just pick up where we left off. So, yeah, I'll just wait till I get a thumbs up in the chat from someone. Otherwise, I'll just chill here. Everything looks good according to Owen. Thanks, Owen. Let's go ahead and get started. This first problem that I've prepped is an actual FRQ problem from a few years ago. It says, let f be a, here, I'm going to pull this up so I'm not just staring downwards. Let f be a twice differentiable function defined on the interval -1.2 is less than x is less than 3.2 with the initial condition that f of 1 is equal to 2. Okay. It says the graph of f prime, the derivative of f is shown. Okay, so I'm just going to go ahead and write down that this is a derivative. Just so when I'm looking at it, I'm reminding myself that that's not f, that's f prime of x, all right? It says the graph of f prime crosses the x-axis at x equals -1 and x equals 3. All right, so -1 and 3, so that means the derivative is 0 there. And then it says it's got a horizontal tangent at x equals 2, okay? Let g be given by g of x equals e raised to the f of x. All right. Letter A, write an equation for the line tangent to the graph of g at x equals 1. This shouldn't be too bad. Remember, in order to write the equation of a tangent line, you need two things. You need a slope and you need a point. Hi, Jackson. How's it going tonight? So if we go ahead and do a slope and a point for letter A, we could first find the slope. Actually, we'll just find the point first. We're going to do it at x equals 1. Okay, so that means I need g of 1. Well, g is defined by this thing right here. So g of 1 is going to be e raised to the f of 1. And f of 1 is actually given to me in that initial condition. It's 2. So this is actually just e to the 2. So the y value of g of 1 is equal to 2. Let's do g prime. So g prime of x, let's first find the general derivative, okay? The derivative of e to the f of x is just e to the f of x times the derivative of f. So it'll be times f prime x, okay? And so then if I need to find g prime of 1, I just do e to the f of 1 times f prime of 1. Now, e to the f of 1, I just calculated above, it's e to the 2. And f prime of 1, I'm just going to use my graph over here. F prime of 1 is right here. It's negative 4. It's negative 4. So that means, let's switch back to red, and that means that g prime of 1 is equal to negative 4e squared. All right, so that's my slope and my point. So now I just write the formula. So it'll be y minus y1, which is the e squared. I've got a hair on this. Hold on. I just can't write on that. Equals, and then we have the slope, negative 4e squared, parentheses x minus 1. And there's no need to put that into y equals mx plus b. That's your tangent. Okay? Great. Letter B. Letter B says for negative 1, 1.2 is less than x is less than 3.2, so the interval given. Find all values of x for which g has a local maximum. Justify your answer. Okay, so first of all, note that it does say justify, which means I'm going to need to use words to explain my thinking. So this is a little tricky because normally we're asked if, the graph off to the side, if this graph has a relative max. But instead, I'm actually talking more about g, which is given by that equation right here, e to the f of x. So be cautious. Don't just look at the graph. You're going to need to think about g as a whole. Well, let's remind ourselves that we just found g prime of x, correct? It's e to the f of x times f prime x. And also recall that extrema are going to occur when the derivative is equal to 0 or the derivative is undefined. Now, I know this derivative is not going to be undefined, so I kind of want to figure out when it's going to be 0. Well, interestingly enough, this e to the f of x is an exponential, right? So I know that it's actually always going to be positive. Okay, it's always going to be positive. So no matter what happens, e to the f of x is some positive number because it's an exponential. So let's consider f prime x and see what happens at f prime x. Well, I know there are two instances. Specifically, I use blue, negative 1 and 3, that f prime of x is equal to 0. But because I'm actually looking for a local maximum, I'm going to want to choose the value that changes from positive to negative. The derivative changes from positive to negative. So I'm actually going to pick negative 1. So this is equal to 0 at negative 1 and 3. But this is the value, negative 1, this one is the value that's going to be a local maximum. And I'll kind of summarize right here. So why don't we start a new sentence. So we'll say g of x has a local maximum at x equals negative 1 since, we'll say since e to the f of x is greater than 0 and f prime of x changes from positive to negative at x equals 1. So that's kind of all the logic I would need to say. G of x has a local maximum at, negative 1. Sorry, I just wrote down positive 1 down there. Oops, so just get the negative in there. at -1, since e to the f of x is greater than 0, and f prime x changes from positive to negative at -1. So if it asked me for a minimum, I would have just selected the 3 because it's a change from negative to positive. Okay, wonderful. Let's go ahead and add a page and try part C. So we'll add a page. All right, let's read it first. It says the second derivative of g is equal to that crazy thing. Is g double prime of -1 positive, negative, or 0? Justify. All right, well, I'm going to go ahead and just grab it. So we'll just, and we'll go to my new page, and we'll paste it down here. Here we go. All right, there it is. And we'll have a little fun here. And we'll just get rid of this, and this, and this. Okay, so we'll use this for part C. Okay. Oh, let's see. We need to go a little bit thinner on the pen. Okay. So it's asking me is g prime of, what is it, -1, or was it? G prime of -1 positive, negative, or 0. Well, let's go ahead and just kind of plug a -1 in. So this is going to be g double prime of -1 is equal to e f -1 bracket, and then what is this? F prime of -1 squared plus f double prime of -1. So it's asking me, is it positive, negative, or 0? So I'm not going to worry about a numeric value. Let's just talk signs, okay? Let's first consider e raised to the f of -1. Let's see. E to the f -1, I know, I don't really care what it is, but I know it's going to be positive. Okay, I know it's going to be positive, so we'll put purple. It's going to be some positive result. And that's because it's exponential, and we know that any exponential is going to be positive no matter what it is, no matter what the exponent is. Okay, even if it was a negative exponent, there would just be a really tiny number because the e to the whatever would go to the bottom. All right, so that's always a positive number. Let's look at f prime -1 quantity squared. And I'm actually just going to clean up my notation a little bit. I don't know if it was necessary, but it just makes me a little happier. I know that f -1 here, I'm going to go get the purple again. I know that f prime of -1 is found on the graph, so I could go and actually find the value. F prime of -1 is 0. F prime of -1 is 0. So this is just 0. Okay, so then we've got positive number times 0 plus, and then I've got f double prime of -1. And in order to understand the second derivative, I need to remember that if I'm looking at a graph of the first derivative, the second derivative is the slope, right? So if I concern myself with -1, I'm going to be in this region right here. I'm not sure if you guys can see that highlight. Oh, yeah, it looks good on the screen. So I'm concerned with this region right here. We are sloped negatively at -1, right? The graph is decreasing. That means that f double prime there at -1 will be a negative number, right? That means that f double prime there is going to be some negative number. Okay? And so then if I just compute this, it would just be a positive number. And then 0 plus a negative number is just going to be some negative value. And some negative value multiplied by some positive value is just going to give me some negative value. And so I know that this thing altogether, g double prime of -1, will be negative. Remember, justify means write words. Well, so g double prime -1 will be negative since e to the f of -1 is greater than 0, and f prime of -1 squared equals 0. Actually, I guess I'm being repetitive. Anyone lagging a bit? Anyone else is lagging a bit? Sorry if it's lagging. Yeah, I don't know. We had lag last time. We actually haven't even done a review, the live review, since last time. So I hope that the lag issues resolve themselves. I apologize if they haven't. Hopefully you can coherently watch the video. If not, let me know in the chat and I can try to restart the computer. I think that fixed, or at least did a little bit better last time. So anyways, what we were saying, g double prime -1 will be negative since e to the e f -1 is greater than 0, and we'll just kind of maybe list all three. So we'll just do comma, that's equal to 0, and f double prime of -1 is less than 0. I guess that's really all I needed to say. I could elaborate a bit more on the fact that f double prime of -1 would be negative because f prime is decreasing. So maybe I could do that right here. Since this is this and this is this, so we'll say, grab this guy, put it down here, and we'll do this one. So this is fine. This is equal to 0 using the graph above. And f double prime is less than 0 since f prime of x is decreasing around x equals -1. And so then I think we're good. I think we've kind of explained our thinking. So we've got all three of the values there. And so therefore g double prime -1 will be negative. Okay. Not much really. So it looks like Jackson says everything's okay. So I hope it's okay. I'll keep going until I hear otherwise. Let's keep looking at the last problem. It's D. It says find the average rate of change of g prime, the derivative of g over the interval 1 to 3. Okay, so I'm going to do the interval 1 to 3. And I know average rate of change for part D. I know average rate of change is equal to y2 minus y1 over x2 minus x1, right? This is just simple slope. When you're doing average rate of change, you don't need to take any derivatives. So I'm going to find the average rate of change of the derivative using the derivative. I'm going to use the derivative values. So I believe the range given was 1 to 3. And the function, so 1 to 3, and I think it was f prime of x. So in order to calculate this, I'm just going to find f prime of 3. Oh, sorry, no, it's g prime. So I need g prime of 3 minus g prime of 1 divide 3 minus 1. Okay, so I know the denominator is going to be 2. Let's go ahead and find g prime of 3. You know what's actually really interesting? I think we already found g prime of 1 above. I'm just going to scoot real quick and check. G prime 1, here it is. G prime 1 is -4e squared. Let's go ahead and just use that. -4e squared. So minus -4e squared is what I know. So I just have to find g prime of 3. So g prime of 3 is equal to, remember g prime was defined to be e f of x times f prime of x. So that was g prime. So I'm just going to erase this and put an x. And then we'll do g prime of 3 is e f of 3 times f prime of 3. Unfortunately for us, I actually don't know this. And there's no way to figure it out. But luckily for us, oops, I just dropped my stylus. That's embarrassing. Luckily for us, this is 0. Remember, it was one of my candidates for Extrema. If I look back at the picture just for confirmation, here it is right here. F prime of 3 is 0. So if I plug that in, if this is 0, then the whole thing is just 0. So I know that g prime of 3 is equal to 0. So I'm going to put that right here. Okay, so I'm just going to take this, and I'm going to delete it, and I'm going to solve this over here. This just becomes positive 4e squared over 2, which is just 2e squared. Final answer all done. No justifying in this problem, so I'm just going to go ahead and leave my answer like that. Find the average rate of change. The average rate of change is 2e squared. No units were provided in this problem. I'm just going to check again. Yeah, there's no units or anything, so I'm just going to go ahead and leave my answer as just the normal 2e squared. Okay? So that is a sample AP problem. It's pretty fun, pretty exciting. Let's go ahead and try some more. I grabbed just one of the random related rate or the optimization problems, and I decided to get the poster one. So let's go ahead and try this one. It says a poster is to contain 100 square inches of picture surrounded by a 4-inch margin at the top, and a bottom's going to have a 2-inch margin. Oh no, 4-inch on the top and bottom. Okay, and 2 inches on each side. Using calc, find the overall dimensions that will minimize the total area. Remember, the function that I ask you to minimize or maximize is the function you need to take the derivative of, and then ultimately set equal to 0 and solve. All optimization problems are essentially the same, okay? So let's see if we can draw a picture. So what's going on here is I have a poster. It's my poster. It's going to have an area of 100 square inches. And then I'm building this like border around it, And the border needs to have a 4-inch top and bottom margin. So this is going to be 4 from here to here. And this is going to be 4. And then side to side will be 2-inch margins. Okay? So it needs to look a little something like this. So let's go ahead and figure out my dimensions. Well, optimization, I'm not allowed to use 2 variables, okay? So I cannot call these dimensions, I cannot call them x and y, because that's going to throw everything off with 2 variables. So let's get a little creative. If I call one of the dimensions x, and I know the area is 100, I know the second dimension is simply 100 divided by x, right? So I'll call this 100 divided by x. Because if I multiply length times width, x times 100 over x is equal to 100, which is the area that I needed. But the poster needs to be bigger than that. So if this dimension from here to here is x, and I add 4 here, and I add 4 here, then we'll call it the length of the poster is actually going to be x plus 8. So the length is x plus 8, and it's the poster and the border. Okay, it's like the length of the entire figure there. And then I can find the width of the entire figure. If from here to here is 100 over x, I need to add 2 here, and I need to add 2 here. So the width would be 100 over x plus 4, because it'd be 2 on each side. The area of the poster is therefore length times width. Okay? And this is the formula that I need to maximize. Before I find the derivative, let's clean this up a bit using distributive property. So the first term is 100. The second term, x plus 4, is just 4x. The third term is 8 times 100 over x is just 800 over x. And the last term is 8 times 4 is 32. So the area is equal to, I guess there's no right order to put this in, so I'll just do 132 plus 4x plus 800 over x. And this is the area that I need to maximize, or excuse me, minimize. So what I need to do is set the derivative equal to 0. So the derivative is equal to, that's gone. This is 4. The derivative of 800 over x is just 800x to the minus 1. So that's going to be minus 800x to the minus 2. So that would be minus 800 over x to the positive 2. So minus 800 over x to the positive 2. All right, and I'll just I'll just get rid of that. Okay, this is the formula that I need to maximize. So really all I need to do is go to my trusty calculator, Calci, and oh, it fell asleep again. It's ironic that my digital calculator has power saver mode. I find that humorous. Let's go ahead and plug this in. So 4 minus 800, we'll just put in parentheses just in case, over x squared. And then I'm doing a little zoom 6. I'm looking for a 0 here. All right, let's figure this out. Let's go to, obviously x represents the like the length of something, so it can't be negative. So let's go from 0 to, I don't know, maybe like 50, and let's go up by like 5s. And let's say y is the area, it can't be negative. And the area is probably going to be, I don't know, pretty big. It doesn't really matter because I'm going to find a 0. Whatever, I'll just make it like 1,000. I'll go up by like 100. Let's see if let's see if this worked. Oh, you know what? Actually, I should be a little careful because I'm going to find the 0. I should probably make x negative, just so I can see what's happening, like where it's going to cross the x-axis. Oh, sorry. Y should be the negative 1. Y should be the negative 1. And perhaps I went too big. Oh man, I really did. All right, let's just shrink this. And you know what? Y really doesn't matter because I want to find out when it's 0, right? It was kind of silly of me to do that. Why don't we just go 10 to 10? There we go. Yeah, it didn't make much sense for me to make y very big because I'm trying to find out when y is 0. This is the derivative here. So I can just do a little second calculate. 0. We're going to do left bound. We're going to go over here, and enter. And we're going to do a little right bound action right over here. And we'll do an educated guess is like whatever right here. So, okay, here we go. We get x is equal to, x is equal to 14.142. And it looks like in this particular problem, we are inches. Reading the problem, it says, what are the dimensions? So that means I should probably give the other one as well. So if I know that x is equal to that, the other dimension, 100 over that, will be 100 divided by 14.142. And that's looks like 7.071. So this is the value of x. So then I could figure out the new dimensions by just adding. Here, you know what we'll do is we'll just get rid of this for a second. This is inches and inches. So then to find the actual length, I'm looking right here now. Let's add 8 to the value of x here. So let's do plus 8. And then down here, I'm going to get rid of my inches. And let's do plus 4. And so that's going to be, let's see, so that'd be 6, 7, 8 is like 22.142. And then 11.071 inches and inches. Okay. So these are the approximate inches of the entire object here. So it's got the border there, and it's got the poster. Cool. All right. Good so far. Oh, we're going back here. Sorry. Not much. Mr. Schachter, do you think you're going to go over the Calc Club today? Also, that's true. Why would a digital calc have sleep mode? And who takes the time to program it? I'm actually not really sure who took the time to program that, and I'm not going to go over Calc Club. I can't go over Calc Club because these videos would live on forever, and the security of Calc Club is very important to the math department. So if you want to go over your Calc Club, and I know period D you didn't have the opportunity to, you can come and see me on Monday morning or Tuesday morning, depending on when your test is. I know period E, it's Tuesday. Period F and D, it's Monday. So if you want to come see me Monday, I'm happy to go over it with you. Also, if you want to just send me an email, I know if you took it today, if you want to send me an email, I can certainly give you some feedback on your particular Calc Club. Okay, so either or should be good. It gives it a more immersive experience. Oh, the pains of not Desmos. And yes, I agree completely, Nick. Desmos is much better. I was actually chatting with Mr. Marley today a little bit about Desmos and kind of using it in the classroom a little bit more with some of our classes. So maybe there's a hope. Okay, are we good with the poster? Is that good? 22 and 11 approximately for those dimensions there. All right. Cool. So let's go ahead and do a related rate problem. So let's get rid of this. Get rid of that. It's going to go back to sleep mode. Just watch. Let's see. The radius of a right circular cylinder is increasing at a rate of 2 inches per minute. Let's write that down. So it says the radius is increasing. So this is, we know dr dt is 2 inches per minute. Okay? And the height is decreasing at a rate of 3 inches per minute. Okay. We also know that dh dt is equal to -3 inches per minute, making sure the rate of decrease makes the rate negative. So it's -3 inches per minute. Additionally, the problem goes on to say, at what rate is the volume changing? So that means we need dv dt. Is the volume changing when the radius is 8 inches and the height is 12? So I'm going to write that over here. Call this my frozen info. Radius is 8, height is 12. And then is the volume increasing or decreasing? Okay, we'll answer that later. So I think we're ready to go. I've got dr dt, dht, and dv dt. So the formula that relates them is simply the volume of a cylinder. So the volume of a cylinder is not given to us, but we know it. It's pi r squared h. I can't plug anything in. If I plugged any frozen values in, of course, that would freeze frame the picture, and then my rates that are changing would no longer be changing. So frozen information cannot be used until after you solve the problem, okay? So let's go ahead and take the derivative. The derivative of the left-hand side is dv dt. The derivative of the right-hand side requires the product rule. That's because r and h are both variables. My suggestion, pull the pi out, and then do the product rule. First times derivative of second is dh dt, plus second times derivative of first is 2r dr dt. Okay? And then it's just a plug game. Just plug it in like Glade plugins, now available in calculus flavors. All you got to do is just put all the info in. So dv dt is what we needed, so we don't know that. So I'll just leave it dv dt. This is pi. R is given to us as 8, so 8 squared times dh dt is negative 3, plus h is 12, times 2 times r is just, r is 8 again, and then dr dt is 2. So I literally just plugged everything in there. And let's just use the trusty calc to figure this out. So what is that? 8 squared is 64 times 3 is negative 192 plus, and then let's try to group some stuff together. It's 12 times 2 is 24 times 8 times 2 is 16, so 384. And then we'll just do a quick minus 192. To get 192 pi. Now this is a rate of change of volume. So I believe it was inches per minute. Yes, so it'd be inches cubed per minute since this is a rate of change of volume. Okay. Interestingly enough, since, and I'm going to add a page to justify, since this rate of change is a positive number, the rate of change of volume is increasing. The problem asked me at the very bottom, is the volume increasing or decreasing there? So the rate of change is positive, which means that the volume itself is increasing. So we'll write down, oh, I didn't actually add a page. Did I do that in the wrong spot? Probably. I wasn't really paying attention. Here's where I am. Okay. And then we'll do since dv dt is greater than 0, the volume is increasing. Smiley face. Okay, that's it. That's all it asked me. All right, your typical related rate. Calc flavors exclusively available in Shack World. Right, and needing Shack bucks to purchase them. Don't forget that. A very important stipulation. All right, I've got one more AP problem for you tonight. This one is just some monstrous function. It looks like it gives you g is defined as x greater than 0 with g of 1 is 2. So I'm just going to highlight that. G of 1 is 2. G prime x is that hideous thing, and G double prime x is that even more hideous thing. One thing to add, make sure your calculator is in radian mode, always in radian mode for calculus, okay? So those of you in physics putting it in degree mode, make sure you put it back into radian mode for calculus. All right, let's jump in, right? So it says find all values of x in the interval, negative 1.2 less than or equal to x less than or equal to 1, at which graph the graph of g has a horizontal tangent line. All right, well, horizontal tangent would mean that the slope g prime of x is equal to 0. So I think all I need to do is to put that into my calculator. So let's go ahead and put that in. So it's sine of x plus, and we'll just, again, just as a precaution, put that in parentheses, 1 over x, close another parenthesis for the sine. And then I'm going to go to my table of values. And, oh, it's not going to be a clean value. Well, I should have guessed it. It's a calculator active section. So instead, we're going to do a little zoom trig. Let's see what happens. It's number 7, zoom trig. Okay. Nice. All right. It looks like I'm given an interval, though. My interval is 0.12 to 1. So this is one. Let's look at my window. So x is going from negative 6 to 6. All right, why don't we just change that, to be honest? Let's go from 0 to 2. We'll kind of overextend a little bit in that direction. Okay, so it looks like I've got a couple of candidates now dealing with, you know what, there's a lot, 1, 2, 3, there's a bunch there, so I need to be a little more strict with my window. Let's just go 0.10 to 2. 0.10 to 2. All right, that looks pretty good. Horizontal tangent is going to occur here, so let's go ahead and calculate them. 0, left bound, let's see, so 0.12 to 1, 0.12 to 1. Oh, we might be able to fit this one. Let's check. 0.16. It's in the interval. So g prime x equals 0 when x equals 0.163. And we're going to have another one, whatever that other guy is. Second trace, 0. And left bound, sure. Right bound, sure. Guess right here. 0.359. Okay, that's all really that A asked for, is when is the derivative equal to 0. That's when you have a horizontal tangent. It doesn't say justify, so don't worry about it. I'm just going to go ahead and move on. B, on what subintervals of 0.12 to 1, that means intervals within the interval given, if any, is the graph of g concave down? So remember that concave down means the second derivative should be negative. All right, so I'm going to go ahead and go here. You know what? I'm going to leave this in here, but just turn it off. I don't know if I'm going to need it anymore. And, oh, you know what? I don't want to type this in. Assuming their calculus is correct, which I'm sure it is, I'm just going to do the math. That's mode. Math derivative. Oh, geez. No, I want it in here, please. Math. It's because I clicked mode first. It's my own fault. X, vars, y vars, function, y1, x. This is just saving me the time of typing in g double prime. I already typed in g prime, so why not just differentiate that? All right. I'm in the interval again, 0.12 to 1. So 0.1 to 2, that's fine. And my y values are going from -4 to 4. That's fine. Let's see what this thing looks like. Okay, so again, what I'm trying to do is prove concave down. That means I'm looking for a negative second derivative. Look for a negative second derivative. Okay, looks like I've got a little bit of it. I think this is outside my interval. Just to be sure, I'm going to go ahead and do 0.12 and check this. Oh, no, I got a little bit in there. I got a little bit in there. All right, that's good. That's good. And I get a little bit more. I get a little bit more up to 2. Hey, iPad, don't go to sleep. Okay, so let's find this one first. Let's go find the 0. I'm telling you, this is so tedious with the calculator. Oh, jeez. Oh, it widened my window out because I went too far. All right, sure. 0.12 is my left bound. There it is. Okay, 0.2, which is good. That's in my interval, 0.222. So g double prime of x is 0 when x equals 0.222. So let's go ahead and just start sketching a little bit of a idea of what g looks like, g double prime looks like. So it goes from negative to positive, and then I'm going to have to find this other 0 that's super far away. Let's go over here. All right, here we go. We're getting close to it. Left bound, right bound. We'll go to the right of it. All right, now we're in the negative. Oh, wow. Oh, I'm not clicking anything. All right, right bound, sure. Yep. I've upset my calculator. Okay, let's try again. Oh, man, it's really frozen. Oh, so, what's up? Just chilling. Okay. Well, I know it's going to go back to the negative region. I just need to find out what this number is. This 0. Anyone in the chat want to find it for me since I broke my calculator? What's that 0? Second, stop. Second on. Whoops. Second, on. Yes, I stopped it. Second, calc. No, it's, oh my goodness. All right, I'll just get rid of it. All right. Yay. Okay, we're back. Second, calc. 0. Go back. Go back. I'm watching my y values and positive y values. Enter. And negative y values. Enter. Enter. Oh, wow. It's 1. Ooh. Can I include it? Yeah, look at that. 1 equals. Okay. So it looks as though we are going to be concave down. So g of x is concave down from, and I have to be careful with my interval here. So I can't say negative infinity to 0.222. I have to say, you know what I'll do is I'll say on 1, no, it's 0.12 to 0.222. Since it does say justify, since g double prime is less than 0 on that interval. Okay, so looks like just that region right there. I do get negative second derivative after 1, but unfortunately I stop my interval at 1. So it's just from 0.12 to 0.222. That's the region in which I'm concave down. Upset my digital calculator, definitely a realistic calc experience. You know it, Jackson. You know it. All right, let's do part C. Okay, part C says, write an equation for the line tangent of g at 0.3. All right, so if I have to do this, all I have to do is just need a point and a slope. So at 0.3, I need g of 0.3 and g prime of 0.3. Okay, I'm going to look up at my problem, and it looks like, well, I don't have g of 0.3. So that's going to be a problem. Write the equation for a tangent line to the graph of g at x equals 0.3. Well, not sure what it wants me to do. Wonder why it didn't ask me to do that at 1 when it gave me the point. G of 1 is 2. Yeah, I don't really know. Write an equation of the line of the tangent at g at x equals 0.3. All right. Well, I can find the derivative at 0.3. I'll just do that for fun. Let's go back here. Let's do this on and this off. And then I'm going to do vars, y vars, function y1, evaluated at 0.3. So I'm finding the derivative, the first derivative at 0.3, and I get negative 0.472. Let's see. Yeah, chat, you got any ideas how to find g of 0.3 or why it's asking me that? Let's see. How to find g of 0.3. Yeah, we don't know. We don't know. Looking at it. Not seeing it. I got g prime. I got g double prime. I got g of 1 is 2. What do we know from part A? What did part A do for us? It told us when g prime was 0. All right, that doesn't help because it's not at 0.3 or anything. And then part B did concavity. Part C is asking me for the equation of a tangent of 0.3. Chat, you got any ideas? Chat's got no ideas. All right, I do have an answer key lurking around somewhere I can check, but I am not sure why It's asking me that. Or how to find g of 0.3, because I don't know g. I don't know g. All right, let's not waste any more time. We got an answer key somewhere here. Let's see. I did all these out. I was going to put the answer key online. All right, g of 0.3 is... I just wrote down the answer. I didn't write down how to find it. That's useless. All right, g of 0.3. Well, I mean, I guess the cheating way is to just use integration, but that's not going to be on your test. There's got to be a way to do it without using integration in antiderivatives. G of 1 is 2. Yeah, I don't know. Boo. I think you need to integrate. Chat. We can just kind of infer from our knowledge of the derivative. Well, unfortunately, the knowledge of the derivative, it's not going to tell me what g of 0.3 is. It can tell me if it's like increasing or decreasing, but it's not going to be able to tell me the value. I guess this problem's a bust. Okay, well, fair enough. I'll just pick up my paper. I'll give you the number. So it's 1.546. I'll put a little star there. Don't worry about that number. How I probably found it is just integrating the function, but that will not be on your test. So just don't worry about omit that part. So really the answer is, and again, it's not to any fault of your own that you can't find that y value, equals negative 0.472 times x minus 1.546. Ooh, that's the y value, not the x value. Let's go ahead and get that in there. So it's 0.3. Okay, so this is the tangent. Yeah, no fun. What do you think, chat? Speaking of which, can we do an antiderivative problem? Yeah, we can totally do an antiderivative problem. Let's finish this up. D, last part of this problem, even though part C proved to be lame. Or not lame, just preemptive. Too much. We shouldn't do that in this chapter. Does the line tangent to the graph of G at x equals 0.3 lie above or below the graph Y? This is a good question. You got to think about concavity when you're talking about tangents, right? Remember that if you have a concave up situation here, I'll write down here, concave up situation, this is concave up. Tangents will always be below, right? Tangents will always be below. And if you have a concave down situation, tangents will always be above. So if you want to figure out if a tangent is above or below a graph, just consider its concavity. So if I go up, I'm considering 0.3. So we'll say since g double prime of 0.3, or actually, no, I won't even say that. I don't even know what it is yet. Let's go look first. Here's my concavity. So 0.3 is going to be on the number line somewhere around here. So I know that the graph is going to be concave up. So since g double prime of 0.3 is greater than 0, g of x is concave up at x equals 0.3. Thus, the tangent will lie, and if you look at the picture again, concave up means that the tangent will lie below the curve, g of x. Okay, so concave up means tangents below. Concave down would have mean tangents above. So that's kind of a nice problem to figure out where it is. Where's the tangent? Is it above or below the curve? So boom. It looks as though we are all set. Above or below? Maybe he's just looking for a general answer. Above or below? Yeah, Jackson, I totally agreed. Part D is doing that. This is the only part, though, I think was a little preemptive for me to pick this problem because we don't know how to calculate that without using integration techniques, which will be taught to you in this next chapter, chapter 5. But for now, you don't know, and you don't need to know. But D is a good question. Definitely need to know that for the test. Okay, we have a little time. I did say I wanted to do a little bit of Q&A, so let's just go down here. Q&A. And I think Nick asked in the chat to do an antiderivative problem. We totally can do an antiderivative problem. I'm just going to make one up randomly and hope for the best. Suppose the acceleration of some particle was, I don't know, I'm trying to make it kind of obscure. We'll do like 2t minus 4. Oh, you know what? Oh, I don't know if I can make these up because the initial conditions, I guess it shouldn't matter. We'll just say, and v of 1 is, oh, you know what? We'll do 0 here. V of 0 is 2. And position at 1 is 10. I don't know. This might fail miserably, and I'll just go find one in the textbook. But let's just try to see if we can do this. So if position, or excuse me, acceleration is 2t minus 4, what you need to do is work backwards to find the velocity function. So essentially, I'm asking you, what function could you take the derivative of to have an answer of 2t? So I know it's got to be squared. This could be squared, t squared. And then do I have to add a coefficient or anything? Well, if I take the derivative of t squared as it is right now, I get 2t as an answer. So that's all set. And then the antiderivative of negative 4 is negative 4t. Again, antiderivative means going backwards. So suppose I started with negative 4t. The derivative of negative 4t gives me negative 4. However, I have to add a plus c, because there are an infinite number of velocity functions whose derivative is exactly 2t minus 4. But there's only one that goes through the coordinate v of 0 is 2. So if I plug this in, v of 0 is 2. So I'm going to plug the 2 here, the y here, plug a 0 here, plug a 0 here, plug a c here. I get the 2 is equal to c. What that tells me is that that value is 2. So velocity is t squared minus 4t plus 2. So this is like one of the functions that I needed to know. And then I just do the same thing using the condition that s of 1 is equal to 10. So let's go ahead and go backwards one more time. So position is equal to a function whose antiderivative is t squared. Well, I know it's going to be cubed. I know it's going to be cubed. But if I took the derivative of t cubed, the answer would be 3t squared. So I need to ask myself, what could I put in the front to get rid of this 3? Oh, I could put a 1/3, right? Because if I took the derivative of 1/3 t cubed, the answer would be t squared. So that worked. The antiderivative of negative 4t, I know it needs to be negative. I know it needs to be squared. If I took the derivative of t squared as it is, I would just get 2t. So in order to get 4t, I just throw a 2 in there. The derivative of negative 2t squared is negative 4t. The antiderivative of 2, of course, is just 2t. It's really easy when it's just a constant. You just add a t to it. And then plus c, of course. And here's where things might get a little dicey. This is a 10, and these are 1s. Okay, let's see what happens. 10 equals 1/3 minus 2 plus 2 plus c. Oh, actually, it's not too bad at all because these cancel. So 10 equals 1/3 plus c. So just minus 1/3. So c is 9 2/3, or whatever fraction you want to do. And that goes here. So s of t is equal to 1/3 t cubed minus 2t squared plus 2t plus 9 2/3, which I guess I'll convert. 9 times 3 is 27, so 29 thirds. And that would be a problem that would require you to go backwards using anti-differentiation. Okay? All right. We did a bunch of stuff in the video. I hope it was helpful. I'll leave the chat open for a second in case there's any other call-outs. But, I would definitely review the topic list we went over in class today or yesterday. If you didn't get that, you can certainly ask a friend or email me. I can send you a copy of it. Optimization, related rates, first and second derivative tests, anti-differentiation, pretty straightforward. It's a smaller assessment because the material is a little bit longer. These problems take a little bit longer to do than a normal problem. Okay, it looks like the chat is happy, so I'm going to call it a night. I hope everybody enjoys the rest of their day and has a nice weekend. Study up. Test is Monday, Tuesday, and go Pats. I don't know why we're in the wild card. We can't beat the Dolphins, but I guess that's a thing. Oh well.